Hello. All right. Now, if you haven't seen already, please take note that I did answer a few of the homework questions from 5.2, which I think most people would have the issue on. If you're having issues in 5.3, what I would do is I can see if I can find some Khan Academy videos, but it's really something from Algebra 2 and Algebra 1 that it should be very familiar at this point. Now, I can understand the 5.2, the 3x3 systems. Yeah, they're hard. Okay, I totally agree. Well, yeah, it is me saying it, I know. They're tedious, and they're really easy to make a mistake. That's what makes them hard. Not that it's hard to multiply and add and subtract and to, stuff like that. It is hard because if you make one tiny little mistake, then there's no way you're going to get it right. So you have to be perfect the entire time. So, other words like me, ha ha ha. So I couldn't help it. I had to say it. All right. And I can just hear you guys cringe. I can just see it right now. All right. What we're gonna do right now is we're gonna do kind of two lessons. I'm gonna do the last two lessons of chapter 5. I told you we're gonna try to finish it this week, so I'm gonna do the last two lessons of chapter 5. These were more systems now, no 3x3 systems anymore, but we're gonna have nonlinear equations. And then we're going to do solving systems of inequalities. Now, I don't know if you remember me saying that we'd have no more graphing this year, but I was wrong. We have some more graphing to do, so I'll try to post some graph paper as well. Yeah, so if you need to print that out or just make your own graphs, it's really not that big a deal. Okay, it really isn't. But yep, there's more graphing, just one. This should be the last. And again, to be honest, that doesn't mean anything anymore because I've said it a couple times now. So anyway, we're going to get started with nonlinear systems of equations. So let's see what we have here. Now, nonlinear systems look something like this. Okay, we have, instead of a linear system, which we have 3x minus y equals 9, we have a nonlinear system. Okay, x squared is equal to 2y plus 10. So here we are going to have two methods of solving. One, we can use the elimination method, all right, and one, we can use the substitution method. So if I wanted to, I could probably try to find to eliminate this y. I'm going to say most of the time, my really go-to suggestion, unless it's automatically set up to use elimination method, my kind of go-to method is substitution. Okay, it seems easier to me. Okay, so we're gonna do both, and we'll just do some examples on here. So we're gonna start with the substitution method, and again, because this is nonlinear, if we have a linear equation, we could have one or two different equations. It's possible to have four equations, okay, or even, four equations, four answers. We could have 1, 2 solutions, or up to 4 solutions, okay? If we have a line and a parabola, 2 solutions, or 1 if it just intersects at one place. Line and a circle, again, 2 solutions, or 1 and it intersects at one place. But if we had a parabola and a circle, then we could have 1, 2, 3, or 4 solutions. Okay, so yeah, be ready for that. All right, you ready? So, solve by substitution. So I'm going to draw on here. I'm just going to do some screenwriting. Here. Need to turn my little writing tablet on. So solve by substitution. Now, since right here I already have y by itself, what I can do is I can take this and I can plug it in for y here. So instead of y minus x equals -2, I can write, and again, you can put it in parentheses, x squared, that's an x, minus 4 minus x equals -2. Now, bring it out of the parentheses because there's nothing to multiply by, nothing to distribute. And we have x squared minus 4 minus x equals -2. I'm going to add the 2 over, and I'm going to put it in order. That means x squared minus x minus 2 is equal to 0. All right. So here we have a quadratic equation, which means I'm going to have to factor. Now again, you can do your box method. Really not too big a deal because there's only one set of factors of 2. So if I remember, it is -2 down here and a -1 here. I don't remember, to be honest. So things that shouldn't have. So what factors -2 combined by -1? Well, that'd be -2 and 1. Since there's no leading coefficient, that's our solution. X plus 1, x minus 2, and when we set each equal to 0, we get x equals -1 and +2. Now, we have 2 solutions for x, which means I'm going to plug in both these values, and I'm going to get an answer for y. So let's plug it into this one because it seems easiest to plug in. It really doesn't matter which one I plug it into. Okay, I can plug it into the top equation. It makes no difference, but since I already have y by itself, I want to plug it in here. So 1 squared minus 4, if I plug in -1, I'm going to get -1 squared minus 4, which is -3. And if I plug in 2, 2 squared minus 4 gives you 0. All right, so 2 solutions, and they both work. So instead of finding just where one set of solutions, here I have 2 solutions. All right, so that's the big difference here. So I'm going to have multiple solutions. So I'm going to do some factoring. So yeah, you got to know your quadratic formula, maybe. Okay, be honest, these are all going to be working out to nice whole numbers, so you can factor every one of these. The difference is you're going to come across some that are like circles. If you remember circles all the way back in chapter, when was that, 2? All right, so yeah, it's been a while since we've done circles. All right, so let's look at another one. Here we're going to solve by, here we go. I'm not going to give you anything like this. Yeah, maybe I might. Okay, it's fine. You don't have to graph any of this, so there's no graphing on this section. Like I'm saying, we could have 4 solutions, we could have 1 solution, 2 solutions, or even 4 solutions here, or 3 solutions if it's something like it crosses, turns, and then crosses again. So, yeah, it's about midnight right now, so that's the only time I get to make these because otherwise my kids are just way too loud. And yeah, I love them, but oh my goodness, you cannot take your eyes off on them because I'll find pen all over the wall, or one of them jumping on top of another one's head. That was fun. So, all right, so we're going to solve by elimination. Now, again, I don't have to solve by elimination. Since I already have y by itself, I can solve by substitution. I'm going to tell you, I don't care what method you solve, just solve it. Okay, even before on the other ones, I don't really care what method you use, just solve it. So, but because it says solve by elimination method, I'm going to do that, and I'll try to do it both ways so you can see it. To solve by elimination, I need to have this x over here, so I'm going to subtract x squared so minus x squared, so minus x squared plus y. So that's going to give me x squared plus y equals 16, and negative x squared plus y squared equals -4. So when you add these together to eliminate them, you get y squared plus y equals 12. So subtract 12 over. Y squared plus y minus 12 is equal to 0. So here I'm going to get, do your box method, because this is a quadratic function again. 1 and -12, which gives you 4 and -3. So x plus 4 and x minus 3 is equal to 0. So x is equal to -4 and +3. And no, sorry, y. I don't know why I'm saying x. Y is equal to -4 and +3. So I can plug that back in here. I can plug it in here. Makes no difference. I'll plug it into the top equation. Okay. Yeah, plug in the top equation. We have plug in for -4. Computer made noise. I don't know why. I guess the video editing I was doing just completed. So let's say y equals -4. We get, sorry, my tablet's sideways, that's why I was writing so funny. X squared minus or plus -4 squared equals 16. So x squared plus 16 equals 16. So that gives x is squared is equal to 0. So when you square both sides, you get x equals 0. So -4, 0. All right. So that's one solution. Then we plug in +3. So x squared plus 3 squared equals 16. So x squared plus 9 equals 16. Subtract 9, x squared equals 7. And when you square root, you get x equals plus or minus square root of 7. Now, where the plus or minus come from? This is asking what square root is 7? Well, positive or negative square root of 7 squared gives you 7, because when you square this, it becomes positive. So you actually have two solutions here. One where, I think I wrote this backwards. Give me a second. X is 0. Y is -4. So here, x is square root of 7, 3. And negative square root of 7, 3. Like I said, you could possibly have 3 solutions. So what it looks like is if you graph this, it's centered around 0, 0, and it goes 1, 2, 3, 4, 1, 2, 3, 4, and I'm not going to draw a good circle, so don't stress that. I'm not going to... There we go, there's our circle. And then we have this equation, which starts at 1, 2, 3, 4. Starts here, starts right on the circle, crosses at 2, and then goes up. Crosses it, and that's a 2, which goes up. So 3 points of intersection, 1, 2, 3, and then we have 3 solutions. All right. I don't think there's much more of these to do, so we may do some practice questions. Okay, yeah, this one. I didn't give you any application questions on the homework, so I'm not going to stress the application question on here. I'm just going to give you straight up word problems. So, not word problems, straight up doing example problems. So let's go ahead and look at one of these questions. I'll write in white that. So. Let's look at this. Well, we just did a circle question. I don't know. Let's look at 32. Number 32. Oops, I forget. Press the pen. Stop scrolling so quickly. Alright, so pen number 30. Okay. Scrolled. Alright, there we go. 32, finally. 32 is this setup where it gives you this, which is x squared plus 4y squared. So x squared plus 4y squared. And I like how they're giving you elliptical. This is actually an ellipse without actually ever showing you how to do an ellipse. So, because we haven't skipped that chapter. We're going to, but we haven't. Because that's chapter 7, where we deal with conics. This is 20. So I like how they give you those questions. It still expect you to know what these are. Now this is a direct variation question, which you probably haven't seen in a while. So here, couple ways I can do this. One way is to solve for y. Okay. Which I'm probably going to do the substitution method. I don't really think I can do elimination method, because in order to do elimination method, I would have to have the same thing, and I don't have any same exponents here. Okay, so I'm just going to do substitution. Let's say I solve for y here by dividing by x. Okay, that cancels. I get x squared plus 4y squared equals 20. And y is equal to 4 over x. I'm going to plug this in for here. All right. Now that's going to give me x squared plus 4 times 4 over x squared equals 2. Now when I square this and simplify it, I get x squared plus, and that's going to be 16 times 4 is 64 over x squared equals 2. Now, I can't do anything with this. So what I'm going to do is I'm going to simplify this by multiplying everything by the lowest common denominator, if you remember that, LCD, which happens to just be the only thing in a denominator, x squared. So everything gets multiplied by x squared. I'll do it over here. So x squared times x squared plus 64 over x squared equals 2. Now everything gets multiplied. So 1, 2, and 3. Oh, sorry, 3. Get rid of that one. All right. So that's going to give me x to the 4th plus 64 is equal to 2x squared. I'm going to subtract 2x squared over. And now we have a quadratic-like function. I happen to pick really one of the hardest ones to do first. That's nifty. Now, let's see. Oh, sorry, this was 20, not 2. So 20 minus 20, 64. Okay, that's much better. I was wondering how I was going to do that. This happens to factor down to x squared and x squared, and you can do your box method to figure out what goes here. Factors of 64 that combine to be negative 20, which happen to be negative 16 and negative 4. So negative 4, negative 16. Now these are both difference of squares, which means this factors to 2 conjugates, x plus 2, x minus 2. This factors into 2 conjugates because again, difference of squares, x plus 4, x minus 4, which gives you 0. So here we have x is equal to plus or minus 2 and plus or minus 4. So what I'm going to do is I'm going to plug that into this equation here. So it's going to give me y is equal to 4 over x. Now if x equals 2, 4 over 2, y equals 2. If x equals negative 2, y equals negative 2. All right. Now if x equals 4, y equals 1. If x equals negative 4, y equals negative 1. So I have 4 solutions, and they are 2, negative 2, 2, 2, and negative 2, negative 2, negative 4, and negative 1, and positive 4, and positive 1. So all 4 of those would be the solution. So yeah, that's probably one of the hardest ones you're going to see, and that will be like number 31 on your homework. And I don't even know if I gave you 31. I think I might have. I don't remember. I'll have to check. So, yeah, I think I did. I think I had you guys go through 35. I think it's, oh, I don't remember. I think I just had you guys go through 27. So I just did one that you guys didn't have to do. Okay, but same concept here. All right, going to do substitution. Going to do some factoring. I don't think you're going to see anything as complex as this one. Okay. So, let me do one more. Let me clear this out. Let me do one more, which is number 26. It's very similar to 25. So number 26, we have in this little setup here, x squared plus y squared equals 5. So it's a circle. X squared plus y minus 8 squared equals 41, another circle. So here it's just honestly going to be easier to do the elimination method. I'm going to change this whole top row to negatives. So multiply the top row by a -1, okay, which is going to give me negative x squared negative y squared equals -5, and x squared plus, I'm going to ahead and multiply that out, y minus 8 times y minus 8. If you know the trick, it's really easy to do, but if you FOIL it, y squared minus 8y minus 8y minus plus 64, that's going to give you y squared minus 16y plus 64 is equal to 41. So what's going to happen here is that's going to cancel and that's going to cancel. Isn't that nice? So that's going to leave me with just negative 16y plus 64 is equal to 36. So subtract 64 over 4. Negative 16y is equal to 28. 32. Let's see here. Oh, yeah, okay. So that is 36. 36 minus 24. That is negative 28. That's not very nice. Okay. See, this is what I'm saying. Sometimes it can be very easy to make a mistake, and I get a little uneasier, like I'm sure you would if you got a fraction. Because I'm going to end up with a fraction, I think. Which is like 7/4, something like that. And that's kind of nuts. I don't want to deal with that. So, that's why I'm checking to make sure I got it right. Let's see here. 541 negative 5 plus 41 is 36. Negative 16, because that is y minus 8 squared. So negative 16, positive 64, yeah. Subtract over gives you negative 28. That's not nice. I don't know why it keeps doing that. Did I keep pressing something? Is that what it is? I don't know why it keeps changing, so 28. If we divide by negative 16, we get, it does reduce by 4 to 7/4, which that is just terrible. Well, I want to make sure. I would love to know if I'm right. Let's see here. Pretty sure I am. Yep. It's 28. That seems a bit mean. I think the one you guys have works out much nicer, so that gives you Yeah, the one you guys have on number 25 works out much nicer. This one doesn't. I think there's probably some kind of typo here on this one, but hey, we'll finish it. This is y, so y is equal to 7 over 4. I'm going to plug that in. Let's say plug in the top one, seems easiest. So x squared plus 749 over 16, because that's 7 and 4 squared equals 5. Subtract 49 over 16. So x squared is equal to 31 over 16. And then we square root both sides. So x equals plus or minus square root of 31 over 4. Well, that's just gross. So 2 answers. 7 over 4, nope, x. All right. So it is square root of 31 over 4 and 7 over 4. And negative square root of 31 over 4 and 7 over 4. Okay. Again, you're doing the odd question, so you at least can check your answer. I'm doing the even question, so I'm just going to assume I'm right. All right. Okay, we're going to move on, though. Again, those are probably one of the harder ones. Again, if you ever have any questions, want to see any more practice questions, really just Google the topic, systems of nonlinear equations. And you could probably find that on, let me see here. Probably find that some, like Khan Academy or something like that. So, for example, let's say we had that. System of Oh, it's right here. System. You don't even spell things correctly, because why would I do that? So right there. Yep, that's a Khan Academy. You can kind of tell. Yeah, Khan Academy video. I guess that thought was a Khan Academy, but it's not. It says organic chemistry tutor, which why? But anyway, so yeah, I would do the Khan Academy video, which is just going to give you more practice questions, and I don't know why it's not going to play, but my internet is having some issues right now. So I live out in O'Fallon and I have Charter. Anywho, I'm not going to stress with it, but that's what you do. All right, so let's look at. Oh, good, you're done. I'm not going to do that. See here. Let's look at the next PowerPoint. Systems of inequalities. So here, what we're going to do is we are going to graph and shade. And again, the really nice thing is this is going to be open notes. Whatever it is I'm going to give you as an assessment, it's going to be open notes. Okay. I may give you a test over chapter 5 and not just worry about a quiz at all. Just go a straight test and then test, give you a quiz over chapter 6 and a test over chapter 6 and 8. So, because chapter 6 is another 4-chapter section, so we'll see. I don't know. We'll have to figure a way how to do this because I really don't know. Anyway, it'll be something. We'll be okay. So systems of inequalities. So what we're going to do is going to first just start by graphing inequalities. Okay. So here we're going to graph this inequality. If you remember graphing inequality, it means shading. Okay. So, and let's just write over here the kind of the rules here. When we solve for y, if you have, and I'm not writing anything since it's in white, I'll do blue now. So when we solve for y, once we have y isolated, this is really useful, okay? Because greater than means we're going to shade up, and less than means we're going to shade down. That is only true if y is isolated. So y must be isolated, like everyone else is right now. Sorry. I can't help but make dad jokes. I've been around my kids all day. Now, another thing that's going to tell you, that this symbol's going to tell you, is if you see greater than or less than, in this case less than or greater than, you're going to have a dashed line when you graph it. Line. If you see less than or equal to, greater than or equal to, you're going to have a solid line. So here's what you want to do first on every single one of these questions, no matter which ones we're doing. First, solve for y. You just want to go ahead and solve for y, because one, it gives you the format you want. Y is by itself. Okay, linear equation, if you remember slope and y-intercept, we're going to start at positive 3. My slope is going to be negative 2 over 1, so that means I'm going to go down 2, so down 1, 2 over 1, right? And then I have my line. All I need is 2 points. I have my line. Just graph the line between. Now, because it's less than, because it's greater than, it's not equal to, this is going to be a dashed line. And I would prefer it to be a dashed straight line, but that's not happening. There's just no way, okay? So it should be straight. We'll see if I can get it that way. Oh, that's awful. Here. That's a little better. Good enough. Okay. Again, arrow goes on and on. Now, because it's greater than, we're going to shade up. Okay, so the up side of this line is over here. Okay, everywhere here is below the line, and this is the up side. Now, it doesn't have to be picky. I'm just going to, again, it doesn't matter how you shade. I'm fine with you just doing, hey, here's a line, 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 line. Good, you're fine. Okay, because I have a computer, I can do this. I kind of like this. So, nice and pink. All right, so you want to make sure you're above the line. Again, I'm not going to be this picky on it. Okay, I'm not at all. But it does help you see shading here. Kind of nice. Everything above the line. There we go. That's how you graph an inequality. And this is just a linear inequality. All right, now not all these are going to be linear inequalities, but this one was. Let me see, did they give us a nonlinear? All right, so here's another example. We got a few examples here. Okay, so we've got some really good examples. All right, so here, now, because I know it is, because I know this is the symbol, y is already isolated, so I don't have to worry about isolating y, which means because it's less than or greater than, first I know it's going to shade down, and that's just terrible. Shade down. And 2, I know that it is a solid line. Solid line because it has that equal to under it. So again, slope, y-intercept. It means I'm going to start at -4, and my slope is 3, which means up 1, 2, 3 over 1. Up 1, 2, 3 over 1. Again, you only need 2 points, but you can keep going if you want. So solid line through your points. All right, that's not bad. All right. So, and it's going to shade down because it's less than, it's going to shade down. So we'll do that in some awful color. I don't know what color that is, but I don't like it. All right, so shading down. Yeah, I told you, awful color. Basically, this is color of what looks like comes out of a diaper sometimes. So, yeah, there's a visual for you. All right, there we go. Solid line, shade down. Again, you don't have to be this picky. You can just do this. Shade down. I'm okay with that too. Okay. All right, next question. If you see anything with just one variable, this is a either a horizontal or vertical line. So if it's just, I'll do both 2 examples. Let me see. Do I have another example in here? Do I have y? Okay, I do. So I'll do one of each. So x by itself, this is a vertical line, and it's that awful color again. Okay, so x by itself is a vertical line. So through -2. So that means I'm going to put a dot here and solid. Okay, and it is a solid line all the way through -2. Now it says less than. This is less than. So where is x less than -2? Well, on the left side. There you go. So there's the shaded inside. Right. Moving on, next question. Here we have y is greater than 1. Let's choose a different color again, because that's gonna be gross. There's another color. It is a color, whether you like it or not. So here, this is greater than, so it's going to be a dotted line. Nice, yeah. And it's going to, because this is greater, it's going to shade. Wow, that's way too thick of a line, so. It's going to shade up. So this is y equals with just y. This is a horizontal line. Hey, buddy. My dog's awoke. Hey, what are you doing? Let's see here. Why are you biting me? All right. Hey, stop it. What? Let me go outside. Give me a second. Let me go take my dog outside. I think he has to go potty. All right, come in. So yeah, I had to take my dog out. So get off. Get the dog. All right. He's super friendly. So horizontal line through 1. Dog, let me do my job. All right. Wait. Okay. Dashed line, so dashed. Okay, this isn't that easy with a dog. Just a huge dog just trying to grab your arm. All right, and it is shaded up, so shaded up. There we go. Again, you're not gonna. I don't know if you're gonna see a lot of these or not. I'm not gonna give you anything like this on a test or quiz. Those are too easy to do. So, all right. Now, this is where we're going to 2 variables, nonlinear inequalities. Okay, these are going to the circle questions are going to be real easy. Okay, so don't stress the circle questions. Let me choose a different color again. I didn't like that one. Let's do purple. I like purple. So here, again, this how we know it's a circle. They're both squared. Okay, and if you remember the formatting, if you have x minus h squared plus y minus k squared equals r squared. If you have anything here, that's your center. Your center is hk. Now, don't forget you got to change signs. Okay, your radius is the square root of r squared. So here we don't have anything in the parentheses, so my center is 0, 0. And the radius is the square root of 16, which is 4. So this means I'm going to start, and that's a 4. Start at 0, go to 4, 4, 4, 4. Now here's the fun part. That rule still applies, okay? That it is a dotted line, or dashed. I don't care how you say it. So, dot, 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 dot. I'm saying dot, 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 so you can hear me say it and make fun of me, okay? Now, it says greater than. Now, where do you think it's going to be greater than? Contained inside or outside? Okay? And if you said outside, you're correct. If you said inside, nope, you're not correct. And the nice thing is you're alone and you don't have to feel embarrassed about saying the wrong thing. Isn't that kind of nice? I'm assuming you're alone. Okay? So, at least you're not in a classroom full of your peers. So, there we go. Greater than for circles is outside, because again, everywhere outside is more than what's inside. Okay. Anything else? Another question like this? Nope, now systems. So here's the culmination. Here's what you would see on a test. Is something like this. Okay. So we need to plot both these. So I'm going to do one in red. I'll do this one in red. So this top equation in red. Okay. And I'll do the other one in blue. Okay, so we can see the whole idea is where we want to see where they overlap. Now I'm going to do this one first because it's easiest to do. All right, first solid line, shading down. There's my slope. Okay, this is the slope and the y-intercept. So starting at positive 2, it's going to go down 3 over 1. So down 3 over 1. Solid line all the way through. There we go. Close enough. Doesn't have to be perfect, okay? Now, the red one, that right there is a parabola. Now, if you remember a parabola, negative means it's going to be opening down, and this is the y-intercept. So starting at positive 4, also it's dashed. Okay, positive 4, it's going down. Now, you could do a T-chart if you want. But to be honest, I'm not going to be super picky about it. It's going to be a parabola. It's going to be going down. Okay. But if you want to do a T-chart to be a little more accurate, probably a good idea. Since we know we have 4, let's go and plug in 1 and 2. And then we'll plug in -1, -2. Just see what happens. So 1 is going to give me 5. No, negative, because it's going to become negative. So it's going to be 3. 2 is going to give me 0. -1 is also going to give me 3, and -2 is also going to give me 0. So that is the axisymmetry here. So 3, 2, 3, 2, and again, dashed line or dotted line or whatever you want to say. Okay. Now the question is, where do we shade? Now for the blue line, we are going to shade down. Okay, so it's going to be in this direction. All right. Now the question is, for the red line, do we shade inside or outside? Okay, inside or outside. Now less than is going down, basically not going up. If it was outside, it would actually be going up. So if it's outside the red dashed line, it would be going up. Less than, it's inside. So we'd have to shade inside. Now, the question we have to really answer is, where does the shading... Oh, that's awful. Where does the shading overlap? Okay, so right here, right in here, the blue and red overlap. So this is your actual answer. Now, if you wanted, again, if you wanted to not shade in the other places, okay, and only shade the inside area, feel free, okay? Or if you wanted to have the way I had it before, and just make sure you highlight the main area, our final answer. Our final answer is this section here that is shaded in. Your answer is not a set of numbers, it's everywhere in here. And if you pick any number, say you say you pick 0, 0, because it's a solution, it'd work. And so you plug in 0, 0 is less than 4, and 0 is less than 2. It works. Okay, plug in -1, -1, it would work. Right. So that is solving systems of linear inequalities. Let's see, we have another question here. Another practice question. No, we don't. Okay. So let's do another practice question from the book, just to make sure we're quasi-comfortable. Again, your homework, I think I just gave you 27 through 49 odd. So let's look at, let's say, number 48. So I'm going to cross this out. You don't have to worry about this. Oops. Forgot to set my pen. So don't worry about that. Okay. All right. So we're doing number 48. Oop. So 48 on page 537, which is x squared plus y squared is less than or equal to 4. Given this little setup here, x squared plus y squared is less than or equal to 4, and x plus y is greater than 1. So again, we're going to do the setup to where I'm going to do one in red. So let's do this top one in red. And let's say this other one, we can do it in black, it's fine. Why do you have your whole mouth on me? Silly dog. All right. Sorry. Yes, I love you too. All right. So again, circle. We'll do the circle first. Easiest enough. Because 1, center 0, 0, radius is square root of 4, so radius is 2. So again, for the circle, the center is 0, 0, because there's no parentheses here, no plus or minus anything. And the radius is equal to square root of 4, which is 2. So center, 2, 2, 2, 2, and it's solid. So solid line this time. Wow. No, not gonna happen. Not gonna make a good circle here. Okay. At least you know I won't be judgy if I see your circles, okay? Now, here I'm supposed to shade because it says less than. Now, less than, where's the smaller area going to be? It's going to be outside. Sorry, it's going to be inside. So I would shade inside my circle, okay? Or whatever proximity of a circle that is. Now, the other one, the line, I'm going to solve for y because you really want to make sure you have y solved for. So x plus y is greater than 1 minus x minus x. Y is greater than -1x plus 1. So now I have y solved for. Notice a dashed line. Because it's greater than, shade up. All right. Slope is -1. Y-intercept is 1. So y-intercept is 1. Slope is down 1 over 1. Dashed line. Okay. And I'm shading up, like we said before. Now, the question is, where does the shading overlap? It overlaps right in here.